Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's program is 25 years of the Hubble Space Telescope. With me here in the studio to review some of the images gathered over the last 25 years is Steve Whitty. Steve?
Great to be back.
All right, well, in April of 1990, the Hubble was lofted into orbit by the shuttle Discovery. The telescope was really the culmination of decades of engineering, design, and planning by both NASA and the European Space Agency. And it was designed to bring us unrivaled views of the universe. At least that was the plan. However, because of a design flaw, specifically spherical aberration, the edge of the mirror itself was ground too flat. The images that came back were out of focus. NASA had a problem. If they couldn't come up with a solution to this problem, they would have a 43-foot, 11-ton, multi-million-dollar piece of space junk. The solution? Corrective optics to improve the images that were being returned. On the left, you can see the before COSAR, that was the corrective optics operation. And then on the right, once they were installed by the first servicing mission back in 1993. And of course, these corrective optics improved the vision of Hubble and brought it back up to its original design goals. All right, well, that's a little bit of the history. Let's get into the images, shall we, Stephen?
Sure.
All right, well, the first image that we want to take a look at is now on your screen. Mars.
Yeah, so 2001, these are both taken in the same year. You go from being able to see detail on the ground on the left there, and later in the year you had a dust storm that covered the entire planet. You could hardly see anything. It wasn't the telescope's fault. That's really what was there.
And those are usually caused by seasonal changes with the warming air rising up from the ground.
Yeah, but some years are much worse than others.
That's true.
And we're talking Martian years, which are like a little over 2 years of Earth.
Of Earth's time.
Yeah. In April of 2001, Mars Odyssey was launched. So they were launching Mars Odyssey just about the time when these images were taken, and you were thinking, well, is Mars Odyssey going to see anything? Well, Mars Odyssey has more than just optical for looking, and it's been a great mission. It is still up there. It's been a great mission.
That's great. Next, we have Jupiter, the king of the planets. Here you see a great shot with the various cloud bands, and of course the most obvious feature there just to the right of center is the great red spot.
Yeah, so when you look at Jupiter in a backyard telescope, you actually can see much of the detail that you just saw on the screen. You can see behind the great red spot, you can see the eddies and the currents, and you can also see that sort of stuff in both of the bands, and just above and below the two largest bands. But you can't see that just whenever you want. You have to wait for the atmosphere to be clear enough to see it, and then it's only a split second.
Well, that's it, the turbulence of Earth's atmosphere. Here we have another image of Jupiter. This one shows the impact sites from fragments from comet Shoemaker-Levy 9 that impacted Jupiter back in 1994.
Yeah, I happened to be living in Philadelphia at the time, and the Franklin Institute there has a couple of wonderful telescopes. They are awesome instruments, except that they're located in the middle of Philadelphia, which has horrendous light pollution. But Jupiter is a very bright target, and so they had the public come out in huge lines, in droves, and I got to see the G spot of the various spots that, as the comet had broken up into a number of spots, in a number of chunks, it landed
the planet,
in
leaving those dark
alphabetical-
images from the dust
That's right.
coming off
Yeah.
from the various fragments.
They landed in alphabetical order, right?
Amazing how that happened. Yeah.
Amazingly. So,
Well,
yeah.
that's the government for you. All righty. Well, next we have. Oh, this one is great. This is NGC 4217. It's an edge-on view of a galaxy. And what's really remarkable about this, we can see not only the dark dust lanes, because we're looking at this galaxy edge-on. It just happens to be edge-on to our view from here on Earth via the Hubble Space Telescope. But if you look above and below, you can see little filaments of dust as well, which I think is truly remarkable.
Oh, it's awesome. Yeah, it really is awesome. This galaxy is thought to be a possible companion to M106, so one of the bright Messier objects. So I've seen that in my telescope in the backyard, if you will. Not my backyard because I have too much light pollution, but I've gone out to the countryside and I've seen it. So this is a galaxy that's about 60 million light years away, which is fairly close by astronomical astronomical standards.
Universe,
yeah,
sure, exactly.
It's not in the local group, but it is still nearby, if you will.
Fantastic picture. Now, what do we have here, Steve?
So this is M83. This is a star-forming area of M83. So M83
Which is a galaxy.
Is a galaxy, yeah. And M83 is in the local group, or it's near it's really nearby. It's about 15 million light years away.
Of course, this starburst birth is caused by dust and gas falling in because of gravity, and stars are being born, as they say.
That's right. So there is some sort of a shock going on, or had gone on in the system, and it had compressed a lot of the gas and dust, and it has formed just an awful lot of stars. And to see it this way, it had to have created a lot of very large stars. So the supergiants that then will go supernova.
The stars who are very big and very bright, but
That's right.
live a very short life.
That's right.
And then, of course, reseed this area with additional elements to form new stars.
The next generation.
Exactly. So I just think that's fascinating. Now this is great. This particular object is located in the constellation of Monoceros, and its designation is V838, if anyone's keeping score out there. And what this is a light bubble, an echo.
Yeah. So the way to think about this image is that there is a central star that has a hiccup. It has a big bright pulse that it emits. But around the object, there is already a cocoon of gas and dust
That has been expelled off from that star.
That's right, and more or less circularly. And so as the light progresses farther and farther out from the star, and you take pictures of it, this light bounces off the gas and dust that's already there, and you get to see the gas and dust in sort of different shells.
The layers as the light moves through?
That's right. Just and so you can see that the pictures were taken from 2002 to 2004, right? So a little over 2 years. So we have in each direction, to the left and right, you have the you've got the speed of light, this sphere going out at the speed of light. So we're talking about a big object here.
Of course, that sphere of gas was sent out prior to the light itself exiting
That's right.
out
Probably
from
quite a
the
bit
star.
prior, since light goes as fast as you can go, and the matter doesn't go that fast.
I just think that the whole concept of being able to see something like that happening in space over a span of 2 years, I mean, we think 2 years here on Earth, I mean, that's a long time, but in space, it's nothing when you're thinking of tens of billions of years.
That's right, yeah, given the age of galaxies and the universe, sure.
Okay, well, I think this first part of the program has been quite interesting. I hope you've enjoyed our quick look. We have more to come in just a few moments. If you have a question, if you'd like to send us an email as we tell you on each show. We have our email address that you can see down there at the bottom of your screen. Please send it to us, and we'll do our best to try and answer your question, or at least read your comments. And coming up next, after Term of the Month, we'll be back with more of these wonderful images from 25 years of the Hubble Space Telescope.
Thanks, Don. The term of the month for July 2015 is focal length. The focal length of a telescope tells you something about the magnification of that telescope. The focal length is the focal length of the primary lens or mirror. For a Newtonian telescope, which is a simple reflector, the focal length, which is the distance between the primary mirror and the X on the left there, where the actual focus is approximately the length of the telescope. For a Ritchey-Chrétien folded reflector, this is the design of the Hubble Space Telescope, it's a little different. So the light bounces off of the primary mirror, that's M1, it goes and reflects off of M2, and then finally the light makes it to the focal point F. So you have to add those distances, M1 to M2, then M2 to F. And you'd think that, oh, well, the focal length, the telescope could be half the size, but because of the shape of M2, the mirror, it's actually much less than half. It's about a quarter of the size. So the focal length of the Hubble Space Telescope is 57.6 meters, but the length of the whole telescope is only 13.2 meters. For visual telescopes, you've got an eyepiece, and the focal length isn't as important. And that's term of the month for July 2015.
Thanks, Stephen, and welcome back to the program. The theme, the topic for this month's show is 25 years of the Hubble Space Telescope. We're taking a look at some of the prettiest pictures, at least for those of us here at Astronomy for Everyone, when we selected them, and we hope that you think they're pretty nice looking too. We're going to continue with that. Our next image is of the Pillars of Creation, as they're called. They're in the M16, the Eagle Nebula. And here's the image right here. They were taken 20 years apart, and they're actually in two different wavelengths of light, right, Steve?
That's right, yeah. The one on the right was the original, and it has this weird cutout at the top that has to do with the way that camera was constructed.
So that little jagged thing is not the fault of their receiver.
That's right. No,
right,
it has nothing to do with that. So they did actually have camera area, but it did different things than this part of the camera that you're actually seeing. So, yeah. And this was one of the iconic images for that. You know, when people thought of the Hubble Space Telescope, they really thought of this picture on the right. For a long time. It appears in some of the Star Trek Next Generation episodes. Picard has it on the wall in his office, that sort of thing.
Sure.
And so on. It appears in a lot of places.
The image on the left was obviously taken just this year, and I believe that's an infrared, if I'm not mistaken.
I don't think so. It could be, yeah.
Are they both visible?
Yeah.
Visible light?
Well, actually, on the left there, you can see through the nebula, and that suggests infrared. Infrared lets you look through
the dust.
Through
we
the
can
dust
see through it where visible light doesn't.
So one of the things that's interesting is that M16 is something that you can see in a backyard telescope, and with an oxygen-3 filter, you can see it from the middle of city centers. Really, this is a gorgeous nebula, even from downtown Detroit. And the other thing that I think is interesting is that this is where stars are forming. We talked about that star forming region in M83. This is the kind of nebula that you have. So you have, especially at the tips of the fingers of the...
Those little nodules at the tip. Yeah.
That's right. So those are the places where there really are stars that are forming. And there are some great images from Spitzer, which is infrared completely, but also from the Hubble showing protoplanetary disks, so little solar systems in formation stages.
Our next image, talk about star-forming regions. This is in 30 Doradus, which is in one of the Magellanic Clouds,
It's
isn't
in the Large Magellanic Cloud, so that puts it at about 160,000 light years away. So for scale, the Milky Way galaxy is roughly 100,000 light years across, so this is certainly outside of the galaxy. You actually have to look kind of mostly across the galaxy and a little to one side.
And of course, the Magellanic Clouds are not visible from our location here in
Yeah,
Southeast Michigan.
we're too far north. They're just a little bit farther south than we can see.
So we can see some bright blue stars, some young stars in the foreground, and then behind we can see some of the dust and gas that was perhaps being blown away by these newly formed stars?
That's right, yeah. And this also has another name. It's the Tarantula Nebula. One of the things that I heard, which I thought was kind of interesting, was that this thing is so bright, this nebula is so bright, that if it were at the distance of the Orion Nebula, which is much closer to us,
yes,
and it's big and bright and stuff, if it were at that distance, it would cast shadows.
Wow.
This is So this is so much farther away and so much brighter that it's a pretty awesome, awesome area.
Indeed. Now this to me is fascinating. In the middle is a star, Fomalhaut, and if you want to explain to our viewers what we're looking at here.
All right. So the bright dot in the center there isn't actually the star. The star is occulted. There's a mask on the Hubble that they can put right on the star so that you can see the fainter stuff right around the star.
Well, yeah, they have to block out the light of the star,
right.
so it would be so bright, sure.
And it's actually kind of a stick, if you will, and it comes down from almost straight up, the little left of almost straight up, down to that section. So what they did was they took pictures of the disk area twice. I think they've actually done it since then as well, a couple years apart. And they saw something that looks like it moves.
Exactly. I've seen a video, and there's been, I think, 2012 was another image, and you can
see it jump,
moving along.
Yeah. Right. So when this came out, it was touted as the first planet discovered by photography, by direct imaging. However, the mighty Keck in Hawaii was doing that to another star, to another planet. Right around the same time, so it's really difficult to say which was first.
But it's amazing that we can see a planet around another star in visible light.
It is true. In South America, on one of the Magellan telescopes, there is a new instrument that should allow us to see planets around nearby stars fairly routinely from the ground. And that's very exciting for planet discovery going forward. So that was just, as we're shooting the show, that was just announced this week. Ah. So new things are happening all the time, and who doesn't like planet discovery? Exactly.
Our next image, when I saw this, we have to have this one on the show. It's officially known as ARP 87. It's a pair of galaxies that are interacting gravitationally with each other, sort of on a collision course. You can see they've probably already done that by that sweep of stars and gas connecting the two.
Yeah, computer simulations show that you'd get that kind of a sweep out. Gravitationally, the galaxies pull stuff from each other, and you get things that should look like this. So I did look this one up. It's 300 million light years away. This isn't terribly close to us. And although it's in Leo, the two galaxies are 14th and 15th magnitudes. So my 10-inch telescope in an extremely dark sky site has zero chance of seeing these things.
So we're talking time-lapse photography.
Time-lapse photography, if you're going to do it from the ground at all, and yet the Hubble gets this amazing detail from that kind of distance.
It reminds me of some of the simulations that our galaxy in Andromeda will go through in about 4 billion years, I think.
Yeah, 4.5, maybe, yeah, 5.
Now this looks like a brightly colored neon sign, but we both know it as the Cat's Eye Nebula, for good reason.
Yeah, so while we don't get to see the Large Magellanic Cloud because we're too far north, they don't get to see the Cat's Eye Nebula because this is almost straight north, right up near the North Pole.
And again, we're looking at shells of gas coming off from the central star.
Yeah, so we call this a planetary nebula, not because it has anything to do with planets. It doesn't. This is a star like the Sun. It has gone through a red giant phase. It has now collapsed, but it has sloughed off maybe a third of its mass at the end of its life, and the mass goes out and you see a nebula. And it is lit up by the central star.
Right, again, the energy from that star. For our next image, this was termed Majestic Mountain.
Yeah, so this is also fairly far south, in the Carina Nebula complex. So I don't think we can see it from the continental U.S. at all.
I don't believe so.
But
I don't believe so.
It's fairly far south.
But what I find interesting about this picture, very similar to the pillars of creation, you see those little nodules.
Oh yeah, absolutely. This is
again,
star
solar
formation.
systems forming.
Yeah, yeah. Carina has Eta Carina is this absolutely ridiculously huge star, and the Carina Nebula seems to generate these huge stars. It's not that far away as things go. It's 7,500 light years away. So it's in our part of the galaxy.
Okay.
That's, we can think of it as our neighborhood.
I love this picture here. This is the Hubble Extreme Deep Field. It's a composite of several images taken from 2004 and I think 2012. What we're looking at is actually an area of the sky that's 1/10 the size of the full moon. So you can imagine that. And in this picture, there are, I tried to count, maybe 3 or 4 stars. Everything else in here is a galaxy. About 5,500 was the count that they gave on the Hubble site. And what I also find interesting is this was just a random shot out into space. So statistically, there's nothing to tell us that this part of the sky is any different from the other millions of pieces of sky that it would take, this picture this size to cover the entire space.
Yeah, it is really quite interesting. You get a feel for how many galaxies there must be to this depth.
Truly, truly amazing.
And some of the farthest galaxies that we've seen are from this field.
These have been some fantastic images. Right here we see a picture of Dr. Lyman Spitzer. The Spitzer Space Telescope that we talked about earlier. And in 1946, Dr. Spitzer was promoting the idea of an orbiting telescope. And specifically, he was talking about a 3-meter telescope up in space. And his quote goes like this, and I'll read it to make sure I get it right. He said, "The chief contribution of such a radically new and more powerful instrument would be not to supplement our present ideas of the universe we live in, but rather to uncover new phenomena not yet imagined, and perhaps to modify profoundly our basic concepts of space and time." Well said, Dr. Spitzer. We hope you've enjoyed this program on the 25 years of the Hubble. You can always check our website. The address, as always, is down at the bottom of your screen. And to close out our program is What's Up in the Night Sky with Stephen. Thanks for watching.
Thanks, Don. What's up in the night sky for July 2015? We just had the summer solstice, so the days are already getting shorter, and the day actually up by Detroit gets shorter by maybe 20 minutes throughout this month. The month starts with a full moon on the 1st. On the 8th, we have the third quarter moon, so after midnight as the quarter goes on. The 15th is the new moon, great for those deep sky objects you wanted to see. On the 21st, we have the first quarter, so it should be up when you get home from work or whatever. And then on the 31st, we have a full moon again. It is a blue moon, according to Sky and Telescope, by their formula, the second full moon in a calendar month. Venus and Jupiter are in the western, just after sunset sky, but they're better at the beginning of the month, easier to see because they're higher than at the end of the month, where they're going to be very difficult to see. Jupiter is getting fainter, and Venus is dropping faster than Jupiter. By the end of the month, it's lower than Jupiter. Saturn, here on the 26th with the moon, at 11 p.m., it's setting around 3:30 in the morning, the beginning of the month. By the end of the month, 1:30 in the morning. Saturn is awesome. It's high in the sky, as high as it gets anyway, and it's very bright, and so on. Uranus and Neptune are accompanied by Vesta. So the Dawn mission recently visited Vesta. Vesta is just not naked eye, so use your binoculars. Uranus is magnitude 5.9, so it's just naked eye. If you really know where to look, you've got a good star chart. Neptune, you'll need at least binoculars. So on the 14th of July, New Horizon, the spacecraft, will fly by Pluto. That'll be our first mission anywhere near Pluto. And so this is where it is. Sagittarius, the big teapot in the south, if you're up north. And it's near a mag 3.5 star, so a pretty bright star. When you zoom in there are two stars. One is right above and one is right below. The one right above is magnitude 10.5, so it's kind of dim, but it's not anywhere near as dim as Pluto, which is 25 times dimmer. But you're always looking for a pattern, so if you've got a star chart, you can kind of see that there's an arc of stars, starting from the upper bit and going around. And that's what's up in the night sky for July 2015.